Okay, do these one more questions, please. See if you can solve for the variables. By the way, at this point you want to pause the video so you can try them out, because the next slide will have all the answers. Okay, for the very first one, you want to isolate the variable, which is why you first subtract both, oops, it's not highlighting. There we go. Which is why you subtract both sides by negative 0.6, end up with this bad boy right there. You want to get rid of the negative, so that's why you divide both sides by negative 1. And lastly, you log without anything written means log base 10. To get rid of an exponent, you just do a log on both sides and then just a log base whatever the exponent it is of. So log base 10 will get rid of the 10 to some power, which leaves you with n equals log of 42.6. You can leave it like that, or you can actually find out what it is by using a calculator. And we move on. Now, over here, when we add log base 5s, you can cancel them out by doing both sides by 5 to some power. When you do an exponent, that usually gets rid of a log. You just have to make sure that the base of the exponent is the same as the base of the log. Now we end up with negative 3p plus 7 and negative 5p minus 7. Probably want to add 5p on both sides in order to have a positive p. Leaving you with 2p, and then subtract 7 on both sides. 2p equaling negative 14, so p equals negative 7. Now for the third one, determine the instantaneous rate of change. You have to find the derivative, and the calculator has a function for it. Can't really show you how to use the calculator via this program. So I just did it using the limit definition of derivative, and I ended up with, as you can see, well, first I wrote the definition without the limit. I simplified what the top's supposed to look like, and I got to cancel out stuff, leaving us with an h. The bottom is going to be h and everything that I had to multiply by, which was this denominator and this denominator. And then I ended up with this after applying the limit, h equals 0. And when you plug in 4, your derivative is 1. Let's move on. Here's the objective. Students will find the area under a curve by counting squares. Wow. So for the first lesson of integrals, you'll see that finding the area underneath is actually another means to finding the distance traveled when you have a velocity versus time graph. So if you were to take the integral, and when I say integral, it's interchangeable in this case with area, of a velocity versus time graph, you actually end up finding the distance traveled. I will talk about it more later. The meaning of the integral is as follows. The definite integral of a function f from x equals a to x equals b gives the way to find the product of b minus a and f of x, even if f of x is not a constant. As you know, the area typically tends to be a width times height. So in this case, this pretty much is telling you that the area would be the integral. Okay, so how far did the particle move between 0 and 6 seconds? So I am interested between here all the way to right there. As I mentioned before, to find if this is a velocity versus time graph, then you can find out what the distance traveled is by finding the integral or the area underneath the curve, which resembles a triangle. So the area for a triangle is 1/2 base times side. You plug in the numbers, and boom, you got your answer. So between 0 and 6 seconds, he traveled 30 meters. But what happens if you have a shape where the area actually goes through, when the graph goes through the x-axis, or in this case the s-axis? Well, we have positive areas, and we would have negative areas. That's pretty much what that would mean. So that's pretty much a triangle. We have a triangle right there, But then we would also have a negative hips, highlighter, a negative area. So all that it really is, let's assume that this is worth 2, this is 2, this is 1, and this is 1, as far as area goes, then the total distance would be, or displacement would be, 2 minus 1 plus 1. The areas that happen underneath the x-axis are negative. So the answer would be 2, since these would cancel. Over here we got estimate the, let me go ahead and use my highlight, estimate the definite integral of the exponential function f of x equaling 8 times 0.7 to the x from x equals 1 to x equals 7. So we're talking about the area right here. So in order to estimate, you pretty much just count how many squares there are, and I can count 1, 2, 3, 4, 5. That this and this can be 6, and then 7, 8, 9, 10, 11, 12, and then this and this could be 13, and then this and this can be 14. So that's kind of how they estimate it to be 14. So if you would have gotten 13 or 12, totally understand why, but I kind of estimated it to be 14. So figure 1.3c shows the graph of the velocity function, blah, where t is in seconds and vt is in feet per seconds. Estimate the definite integral of vt. So, well, that's going to be very involved. 1, 2, just kidding, that's not how we're going to do it. So what I did here is I first created some rectangles to eliminate squares that I have to count. But at this point, you probably won't have to count squares. So let's go ahead and do that. It's going to be tiresome. So you have 1, 2, 3, 4. Let's call that 4, 5. Let's say this entire thing is 6. So we got, no, that doesn't make sense. Well, 6 squares times 0.2 because the width of each one is different. And then we got, let's just count squares. So we got 6 right there, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26. Yeah, 26. Alrighty, so we have 18.4, and then we have to do like whatever number of squares we got, we have to multiply by how much each square is worth, and each square is worth 0.1, I believe. So whatever number I just said, just multiply by 0.1 and add it to 18.4. Unfortunately, I forgot how much it was, so you already have it in this video, so please do that and see if you get a number close to what they got. They got this number. Let's move on. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. Of the following, which best approximates the total number of barrels of oil that passes through the pipeline that day? So, barrels per hour and number of hours, that's a rate, and a rate times the time will give you the actual number. So, we have to find out what the area is. We certainly have 100 right here. And we have 100 right here. Sorry, that's 600. So that's 600. And then we have 600 and 600 and 600. And then over here, these could each be 1, so that's 600 here as well. So you kind of like estimate how much that would be. So I would say roughly 3,000 would be the answer. In figure 1.3J, a car is slowing down from velocity, boom, estimate the distance it travels in time t 5 to 25 by finding the defined integral. Alrighty, so from 5 all the way to 25. So we care about this area right here. That's the area we're looking for. So go ahead and see if you can get an estimate before I give you what I got. So there are definitely 3 whole boxes here. So that's 3 times however much each box is worth. This is 5, that's 20, that's 100. So 3 times 100 is 300. And then we want to find out what these are. I'm going to go ahead and say that this, and this will be about 3 boxes. So 3 times 100, so about 600. Or you could do it individually. Let's see if, so 300 plus 300 is 600. Or you can do it individually, saying that this one right here, I would give that like 80. This one, 70. And then this one, 90. And this one, 50. And then see what it comes out to be. See if that would be close to 300 as well. 5 and 9 is 14, 21, 29. So it was a pretty good estimate, I suppose. Again, you're kind of just estimating these areas. So if you did it this way and ended up with 590, or this way and ended up with 600, it's pretty good in my opinion.